is Rishika Jain. I am from Sagar. I am doing my graduation from Dr. Harsingha University in Chemical Sciences. I am a last year student and this year I will turn into a graduate. Now, today I am here to explain you a topic named structure of the atom. Now, structure of the atom is basically based on the model proposed by scientist named Neil Bohr. Means the model we are studying today is based on the model proposed by scientist Neil Bohr. Before him, many scientists tried to explain the structure of the atom but failed due to the drawbacks present in their model. Today we will discuss about such models and their drawbacks, as well as we will discuss about the gold foil experiment, which was a revolution in finding the structure of the atom. We will start with J Thomson model. Now, the first most scientist who gave the model of an atom was scientist named J Thomson. Now, his model was much more similar to that of a watermelon. Have you seen a watermelon or a plum pudding? Plum pudding is not much relatable, so we will discuss about a watermelon. Watermelon is what? A spherical body enclosing red pulp inside it. And some seeds are embedded in it. Yani we can see some black seeds embedded in the red pulp, right? Similarly, his atomic model was like atom is a spherical body in which positively charged cloud is present, atomic cloud is present. And in that atomic cloud, some negatively charged particles are embedded all around. Now, this was the model proposed by him. He also stated that the negative charge is present in an atom and the positive charge is present in an atom are equal in magnitude. Therefore, they neutralize each other and make themselves stable in the environment. Now, we will discuss about the drawback of this model. The drawback was related to the mass of the atom. We can observe that the scientists observed that the mass of an atom was much more larger than that of the summation of the masses of positively charged particles and negatively charged particles. When these two particles and their masses are combined together, it was much more lesser than that of actual mass of an atom. So therefore this model failed because there might be some other subatomic particle is present which is having some weight and which is neutral in nature, but we didn't know its position. So the model failed due to some mass related drawback. Now we will further discuss about the next model that was proposed by scientist named Ernst Rutherford. He performed the revolutionary gold foil experiment. Now you will say, what is revolutionary? Because he found the nucleus. You will say, ma'am, nucleus is what? Nucleus is very small thing, and today we'll discover the nucleus. What will be the discovery? But previously no one was knowing that an atom is consist of the nucleus. So it was a very large discovery and it made clear about many things about the structure of the atom. So we will discuss about the experiment. He took a gold foil, as per the name of gold foil experiment. He took a gold foil. You know gold foil? You might have seen aluminium foil and silver foil for sure. In your household, mummy packs your tiffin and all, your rotis in a aluminium foil. Yeah, and as well as we have seen sweets and covered with silver work. They look so beautiful. They seem so delicious, right? Like Kaju Katli and Motichur ke laddu have some silver work over them. What is that? That is silver foil. Similarly, he took a gold foil, a very thin sheet of gold, that is a gold foil about 1000 atom thick. He took that and passed alpha particles through it and placed a screen around it. Okay, you will ask, what are alpha particles? Alpha particles are positively charged particles which are none other than that is helium plus 2 ion. Alpha particles are helium plus 2 ion, which is positively charged. Plus 2, that means positively charged. Helium plus 2 ion is a positively charged particle which is also known as alpha particle, and the rays comprising alpha particles are known as alpha rays. So he bombarded this gold foil with alpha particles and placed a screen all around it. Now what happened? He observed some things. The first thing he observed that the many rays passed straight forward through the gold foil without facing any deviation. So this was a very unexpected result because previously the model proposed was having that is positively charged cloud. So there might be a large number of deviation in the rays, but there was no deviation in maximum rays. So therefore, they concluded that there might be some empty space is present, or most of the space inside an atom is empty. They concluded that is Rutherford and his co-workers concluded that there might be some empty space present all over what, that is all over the atom. Now the second thing he observed that some rays faced some deviation when they passed through this. They faced some deviation, they some move this side, the some move this side, they faced some deviation with some angle. This was very much expected result because there are some positive charge bodies are present in an atom, so there will be some deviation. This was very expected result. The third result was some of the rays strike the gold foil and bounced back by 180 degree. Okay, they strike the gold foil and bounced back by 180 degree. This was not expected. So the scientist Rutherford concluded that there might be some positively charged atomic body, very small atomic body is present at the center, which is known as nucleus and comprised of positively charged particles as well as neutral particles. And he also stated that the electron is revolving around the nucleus at some orbit and is rotating in a circular motion. He also stated that the most of the space in an atom is what is a empty space. Now what was the drawback? The drawback was he can't explain the stability of an atom. Now for example, you tie a ball in a thread and you will rotate around it like that. After moving it regularly, you will find that ball will leave its orbit and will be pushed out or thrown out. Similarly, when electron is revolving around and around, it will gain some acceleration, and when it will get excited, it will leave its lattice. So the atom will become, that is, unstable. So it can't what we can see, survive in the environment, right? So it was the drawback of this model. He can't explain the stability of the atom and the revolution, or we can say the circular motion of an electron. I hope this cleared your doubt about Rutherford experiment or gold foil experiment. Thank you so much.